Linear relation and rate of change. We are trying to model the situation, and in all these situations we have a constant rate of change, and therefore it can be represented in the form of a linear equation, which is y equals to mx plus b. Here m represents rate of change, a constant rate of change, and b represents initial value. Correct? So let's go through these questions and then write our equation. Question number 5. Tom started 12 meters from his house and walked away at a speed of 7 meters per minute. So what is the initial position? Tom started 12 meters from his house. So B is 12 meters. And walked away, that means distance is increasing, right? At a speed of 7 meters per minute. So whenever you see this kind of a ratio, per hour, per minute, that is the rate of change. That means that every minute distance is increasing by 7 meters. 7 meters per minute. So that becomes rate of change. So we can model this situation algebraically in the form of a linear relation, y equals to mx plus b, where y is the total distance, m is the rate of change, x is the independent variable, time in this case, time in minutes, and b is the initial value from where Tom started walking. So we get our equation y equals to 7 is the 7 meters per minute. So 7 is rate at which Tom is walking away. So distance is increasing, correct? So it is positive. 7x. X is time in minutes, plus initial value, which is 12 meters, right? So every minute Tom will be 7 more meters away from his house. So that is how you can explain this equation, correct? Let's move on to the next question. Question 6. A family returning home are 215 meters away. So that is the initial position, 215 meters away. And a family returning home are 215 meters away and are approaching at an average speed of 80 kilometers per hour. Now, when you are approaching, distance will decrease. Therefore, this rate of change here is, rate of change should be equals to minus 80, since the distance is decreasing. So whenever you are approaching or coming towards, we have negative value with the rate of change, correct? Initial distance, that is b, is 215. And now we can write down our equation. Our equation is y equals to minus 80x plus 215. Now you can explain what is y and what is x. X is the independent variable, time in hours, and y is dependent variable, distance from home in kilometers. Do you get it? So that is how we can explain our variables and represent the situation algebraically in the form of a linear equation, correct? I hope you understand and appreciate the concept. I'll appreciate if the next set of 4 questions, 2 plus 2, you do them on your own. Thank you and all the best.